started recording the class. Okay, so today we will be studying about principal focus of a convex mirror. And keep in mind that in this chapter we become a little bit stepmotherly. We love concave more. We'll be loving convex less, but we need to study that also. So our next topic for today is principal focus of a convex mirror. A convex mirror is a mirror which bulges outwards. So this is my convex mirror, right? And obviously I will etch it on this side. And once I have made my convex mirror, I should be able to draw my principal axis. Now children, once I have drawn the principal axis, the pole will be here. The center of curvature will be now behind the mirror because you are drawing a convex mirror. Okay. So what we will take, we'll again say coaxial or paraaxial rays. Rays which are parallel to themselves and will be parallel to the principal axis, close and parallel to the principal axis. So let me take some rays. Okay. Say this is ray number 1. Okay. And then, sorry. This is ray number 2. This is ray number 3. And this is ray number 4. Children, these rays are very close to each other. And another thing that you should appreciate here is that these mirrors have very big curvature. Although you're seeing a very, what you call, magnified version of the diagram. Although you see a curved surface out here, when you go to grade 12, you'll be seeing that in every analysis, they will say, this is almost a straight line. Means the mirror is having a very big curvature. The rear view mirror that you see on your cars, don't you think it's a straight surface? But it's not straight, it's a convex mirror. But are you able to make out that bulge? No, you're not able to make out a similar thing. So keep that in mind. Now hang on, do not draw the diagram right now. I will be doing some jugglery because I want the diagram to look correct. So you will wait till I am done. Okay, don't draw the diagram now. And you will not draw in this process, you will understand first. Wait for me. And whatever I am doing is not the correct procedure. I am doing it so that it looks correct when I am trying to draw it from this side. Okay. Now look at the first ray. The first ray is coming and hitting on the surface. That's the convex surface. The first ray, now you don't expect the ray to cross across a mirror. This mirror will not diverge the ray. It will, sorry, not converge the ray. It will diverge the ray. So this ray will get reflected. This ray will get reflected in this manner. Hang on, I'll give you time to draw. First, see what I'm doing. My second ray, after reflection, will go out in this manner. Okay, don't draw anything, just see what I'm doing. My third ray will come out in this manner. My fourth ray will come out in this manner. Now look at the reflected rays. I can do different colors on this software. Okay, the rays came paraxial and they, after reflection, became divergent. They have diverged out. Do you expect them to meet anywhere in near future? No, they're not going to meet. Our children now want independence. They have gone separate. But there was once upon a time when I extrapolate this, that's why I drew this first, so that it looks correct. If I extrapolate them, then it comes to the same story. हम एक ही जगह से आए थे. We had come from the same place. Our origin was same. Do you understand? And what I do now is that I encircle this portion now, and this is called as the principal focus. I'll give you all time, just hang on. Principal focus of a convex mirror. So if I try to define it in English, the principal focus of a convex mirror is a point on the principal axis from which paraaxial rays close to the principal axis, close and parallel to the principal axis, appear to diverge out after getting reflected by the convex mirror. If I just translate it in Hindi, it says that this focus is a point. ये point principal axis पे है. कैसा point है? What type of point it is? It is a point from which these rays appear. Don't use the word originate. You say appear to diverge out after being reflected by the convex surface. Now this point was formed by the intersection of dotted lines, not solid lines. Means actually these rays never intersected here. It was our assumption. And why are we so interested about this intersection? That I'll tell you after this. We want to find the point of intersection, which actually did not happen. So we extrapolated. What do? We extrapolated and got a point. That's why this focus will always be known as a virtual focus. This is the big difference. The other focus was a real focus because actual intersection of rays took place. Over to you to make the diagram and to write the definition. If you want me to narrate, I can narrate once again. First you make the diagram, then I'll tell you why am I so hungry after this intersection, okay? First make the diagram properly. And to make the diagram, children, use your protectors. Protectors are the best way to make your mirrors. Use a protector and keep a protector as a part of your, or a protector or a small bangle, whichever you have. If your freehand curve is not that good, Karlo. Oh yes, or those type of scales. That is a very good device. I have one more, you know, I bought it after seeing it in Amazon. You can draw parallelograms and it has got a wiper sort of a thing to make angles. First of all, draw the diagram and understand the diagram. Raghav, have you understood the diagram? Parallel rays go and hit and they'll all diverge out. Where did they diverge out from? Sir, somewhere here was their origin. That origin is known as the principal focus. And as the principal focus lies behind the mirror and it has been formed by not actual intersection of rays, I call it what? Amish, virtual. ये wrong हो जाएगा. ये चीज, this have to be seen. This is ना. How can the ray go like this? This ray should. That's why I did my diagram like that. This ray should be like, these two are almost correct. It should have been like this, sir. So better what you do, first you do like me and then exchange this. See, the best way to draw this diagram is to draw the way I drew. That's a dishonest way of drawing, but the dishonest way will give you a correct diagram. If you actually draw the divergence, how do you know that they will meet at the same point? So first you make this part. That's the reason every class I say, I'm doing a dishonest activity, wait for me. Amish, you understood it, right? So first you make these dotted lines and then extend the dotted lines. Your diagram will become absolutely crystal clear, perfect. Don't draw this. Dekho bacha, sab log. Don't draw this and this. First draw this, tuck, 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 and then tuck, 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 wow, like that. Done. Freehand sketches should be fast. No college teacher in grade 11 will wait so much time. By that time, they'll start drawing another diagram. So have you written the definition? Anyway, this is being recorded this time. Don't worry. So definition is the principal focus of a convex mirror. And you write your own definition. You're good in English. All of you all try to find first. The principal focus of a convex mirror is the point where on the principal axis, what happens? What is so special about this point? From where rays parallel and close to the principal axis appear to diverge out. Use the word diverge out. A point on the principal axis from where rays parallel and close to principal axis appear to diverge out after getting reflected by a convex mirror. How much time it takes? All y'all are LL, lazy Latifs. Bugs Bunny. Written. Anurag sir. Done. Writing. Oh, the diagram is done. The writing is still pending. Okay, please do it. And why is it called a virtual focus? Because it is okay. Because in your language, Sri Shreya, I am using Instagram language. Because it is formed by non-actual intersection of rays. Non-actual, or you can use the word 1 minute, dear. Whoever is calling me, just give me 1 minute. Non-actual, give me 1 minute. Or use the word extrapolation of rays. Yes, dear. Somebody was calling me. Sir, what does it say after rays? Where? This one, a point on the principal axis. Rays parallel. Better start using some shortcuts. Rays parallel and close to the principal axis. Parallel, I'm using the mathematical symbol of parallel. Two lines appear to diverge out after. अरे खत्म करो, ये फोकस पे कब से बैठे हैं हम लोग? Oh my God, OMG. Becoming a skibidi class, you know. Ved doesn't laugh. According to Ved, now he's grown up. What's all this skibidi all about? Loki dead. Done. चले आगे. Shall we? Share done. Atre done. Aditi, shall I go ahead? Okay. I'm going ahead now. So are we fine now? That is all about the convex mirror that we study. And now we'll say, you child go to sleep. We'll again pick you sometime later. And now we'll go with our cuddly boy. Who is our cuddly boy? Concave mirror. Done. So far what you have learned? You have learned all the terminologies. You have learned what is about a focus, what is a pole, what is radius of curvature, what is center of curvature, what is principal focus for either type of mirror, what is a convergent mirror, and what is a divergent mirror. That means this mirror will be known as a divergent mirror. And the former one was known as a convergent mirror. Shall we? Okay. Now starts the interesting part of the movie. Now we will see image formation. Before image formation, we always need to know. Before my class, I always say some rules. The rules are important. So we will see rules for image formation. And that's for our favorite boy. Who is our favorite boy? Concave mirror. Oh my God, concave mirror. Okay. If you are drawing along with me, children, please draw. I'll draw one diagram. You draw 5 such diagrams, 4 such at least. Okay. And then it will become easy, because we cannot draw all diagrams out here. Here you need to understand first. Chalo. Look what I'm drawing. Right? This is your base diagram. Make this diagram at least at just this much. Make this at least 3 places. P, F, C. Itna bana lo. At least 3 places you make this diagram. It will be easy for you to understand. In the meantime, I'm trying to make it smaller so that I also do that. Oh, sir, it's so easy for you. I wish it was so easy for us also. What is happening? None. Chalo. Rule number 1. Now listen to me how I write it. Rule number 1. Array. Array means this will all be incident ray, IR. Array. Okay, array. Now I'm writing in shorthand. Parallel to principal axis, and this arrow I'm writing in short. It means passes through focus after reflection. Children, I'm using shortcuts. Array or incident ray parallel to principal axis will pass through focus after reflection. You should not write in this way. You will write in English. You are a mazdoor. Remember that. Array parallel to, or can write, don't write a ray, you write an incident ray. After reflection. Okay, I'll narrate it once. An incident ray parallel to the principal axis passes through focus after reflection. So please wait, understand what it means. An incident ray parallel to the principal axis, got it? Passes through the focus after reflection. This is your rule number 1. Have you understood? An incident ray, एक रे जो principal axis के parallel है, reflection के बाद focus से गुजरेगी. Yes, that's why, darling, there are some 4 laws. That's why I made you draw 4 Puran Polis, not just for fun. Incident ray parallel to principal axis passes through focus after reflection. Are we fine? We don't have the whole day. Okay, children, next rule. Rule number 2 is just opposite of it. It's just opposite of it. So I will first draw the rule so that you can understand. I will first draw the rule so that you can understand how to frame the rule. A ray of light, incident ray, passing through the focus will become parallel to principal axis after reflection. Just opposite of this. You can draw this in a different diagram. I have drawn it in the same diagram. Okay, want to see it once more? Let's see it once more. It's like this. A ray of light passing through the focus, it has to pass through the focus after reflection, becomes parallel to the principal axis. So I'm now writing in words. An incident ray passing through focus. You will write it only in English. Passing through focus becomes parallel to principal axis after reflection. REFL to the power n. You don't write REF to the power n. वो refraction भी हो सकता है REFL. Shreya, is it clear? Have you understood these two? Yeah, the first one is very easy. If you are parallel, you pass through the focus. Look at me once again. If you are parallel, you pass through the focus. If you have come through the focus, you become parallel. Simple, bhai. Yes, na? Anurag sir, all okay? Yes. ठीक है, देखिए सब? Yes, sir. Clear? Great. Have a white big copy, sir. Sir, yes. All these spiral bound and cosmetic ones you can use to make your fresh notes. When you come for class, it is better to keep white. White is very good for scribbling. That is a much more premium copy, which we can use to make up. But anyways, you will now think, does he mean to say he wants me to make notes twice? I'm already fed up making it once. that you can use for your premium task. Science should always be, at least biology, physics should always be in blank. You'll go on coming up with diagrams. And this year I will see your Hydra diagrams, though I don't teach, because last year I had the best of the Hydras in my batch. Somebody, I could not make out whether it's a birthday candle or a Hydra. So beautiful Hydras. Oh, what is a Hydra? Hydra is a guy, you know, he stays in Ramki Towers. You don't know? Hydra? Oh, in context, Hydra, okay. There's a subject called civics. There we learn about Hydra. Okay, rule number 3. Rule number 3. Listen to me. Listen to the rule. Okay, first look at the rule, then you can frame your own way. A ray through the center of curvature. Incident ray through the center of curvature after reflection goes back in the same path, means it is undeflected. If you are coming through the center of curvature, you reflect back undeflected. ठीक है, तो उसी को इंग्लिश में लिखेंगे, an incident ray through the passing through what? Center of curvature C is reflected back in the same path. Which means this is undeflected. Is reflected back in the same path. Tell me now how difficult it is. Children keep on saying, sir, rules for image formation, they are like remembering my grandfather or grandmother. Nothing like that. Parallel to principal axis, through the focus, parallel to principal axis, through C, undeflected. Bas. Have you understood, children, so far? You're very good. You're very intelligent children. Really appreciate your knowledge. Okay, rule number 4 and the last rule. Rule number 4. In order to understand rule number 4, before we write it, because once you understand, nobody's going to take off your marks if you're grammatically wrong, but you should know. So let's understand what is rule number 4. Rule number 4 will be an incidence at pole, means P will become my point of incidence. Now, what is this portion, beta? This portion is a portion of a circle whose radius is CP, right? So just for 1 minute, I'm changing this slide. So this is something which you'll learn in mathematics in this year, but try to absorb. This is a circle, okay? This is a circle, sorry. This is a circle. This is just for knowledge purpose. And this is my radius. So the radius keeps on moving. This is my radius, okay? So imagine this is the radius, which is like a part of the principal axis now. Clear? Now, this is my P, which is known as my pole. At pole, I will draw one tangent now. In that case, this particular point is known as what, children? This is mathematics, huh? Point of contact. Point of contact is the point where the tangent touches the circle. And obviously, I can draw a radius at the point of contact. The radius at the point of contact is always perpendicular to the tangent. This is a theorem which you will study in grade 10. Is it clear? Now, put this story into our physics. Circle is abolished. I have a concave mirror. Radius is a part of the principal axis. Agreed? And point of contact is the point of incidence. And you are making 90 degree, means in other language, what we are trying to say, the principal axis itself is the normal. And if I consider this as a plane mirror, if this is a plane mirror, then the principal axis itself is a normal. And then you apply your grade 8 rules. What are the grade 8 rules? Sir, in grade 8 I never studied. Okay, please study. Angle of incidence is always equal to angle of reflection. This is grade 8. Angle I is equal to angle R. Hai. So same story. Now 1 minute later. So 1 minute later. So how it will be? We will say that the angle of incidence at the pole is always equal to the angle of reflection. But sir, why are you saying it like this? Don't you think that laws of reflection always says that angle of incidence is equal to angle of reflection? So we need to change our words. We'll say the angle made by the incident ray at the pole is always equal to the angle made by the reflected ray at the pole. Does this not happen everywhere? No, it doesn't happen that way, but if you make the normal, it happens. But at pole, a unique conjunction happens. At pole, a unique conjunction happens. What happens? This sort of a phenomenon occurs. That at pole, the radius of curvature or the part of the principal axis becomes the normal. This is like a plane mirror. So angle of incidence equal to angle of reflection. So now we write our law, and we write it that my law number 4. Okay, and then you can take your time and draw. I'm just writing the angle of incidence at pole is equal to the angle is equal to angle of reflection at. Or if you don't want to write it like this, let me make it much more better. We will write it in this language now. Wait, we'll write 4th angle between incident ray and principal axis at pole is equal to angle between reflected ray and principal axis at pole. Whatever you write, the angle of incidence at pole is equal to the angle of, means this angle, if this is angle theta, okay, you don't know what is theta. Okay, we'll do like this. If this angle is x, this angle is also x. Okay. So the 4 laws, we will be using these laws extensively. Now comes, sir, which laws we will be using more extensively? This one and the first one. काम बन जाता है इन दोनों से ही. Understood? And now you will find the section which you will find most difficult to swallow. But there is a technique in which it will become left-hand job. This is being taught in your school. My job is to make it easy for you. Image formations. Tell me now, all of you, online, offline, have you understood the 4 rules? Parallel, through the focus, parallel, through C, undeflected, angle between incident ray and principal axis at pole is equal to angle between reflected ray and principal axis at pole. All of you clear? Which one, Bitu? You want me to explain the 4th ones once again? Oh, you want to write it? Yeah, please write it. Oh, you want me to wait? Yeah, I'll wait. Neil, darling, all okay?
Yes, sir.
Very good. Your mirror is having so much of sharp edges. It looks more like a murdering tool than less like a mirror. If you see the Spider-Man cartoons of 1960s and 70s, and Spider-Man this season has been one of the most fun, and they talk like this. His mirrors look more like sharp edges used for murdering or slitting the throat. Spider-Man in color. Friendly neighborhood. Shall I?
Yes, sir.
Hey, Anurag, You're almost writing like fairy tale stories now. Like slowly. Once upon a time, there was an incident ray and the reflected ray. They lived happily ever after. Children, turn the page. Shall I? Yes. Good. Okay. So we go to our section, which is actually the most, I'll not say hated. People find it difficult, but it's not difficult. Image formation. Image formation by a concave mirror. Now, your problem is that you all don't understand. Acha. Now here we will see, you know what is mama, the maternal uncle? Maternal uncle, my mother's brother. So that person is mama for me. My mother for those kids will be bua, which in your Telugu is pinni, right? Or the paternal sister. So we will see some mama bua combinations out here. What is mama for me? For the mama's child, my mother is a bua, na? Same. Chale, chalte. Number one. Object at infinity. Okay. Object at infinity means the object is placed at infinity. When we do image formations, children, when we do image formation, don't just gulp it. What we are going to study is, we will have an object, okay? We will have an object, and this object will be placed at different positions. Px means different positions. Have you understood? And for ifs, like it will be at px1, it will be at px2, blah blah blah, it will be at some px3. So for every these positions, you will get different image positions. Obviously, for every object position, I will get a different image position. Anna. So my image positions will be something like ix1, ix2, different. In all these scenarios and problems, all we are supposed to say is PNS, position, nature, and size of the image. That's all. You have to comment on position. You have to comment on nature. You understand? Nature means nature. Nature. It was like that. A child, after reading nature, he read a storybook, and there was something called, this word was there in his storybook. This word was there. So this becomes fachure. Okay. So we have to comment on position, size. When we talk about position, children, position, all you have to say is in front or behind the mirror. That's all. In front or behind. And all these you have to comment for the image. Huh? All these you have to comment for the image. Anyway, object, you know where it is. This is what we are going to do. You have to comment whether it is in front or behind. We kept a position px1. We got an image ix1. And that image is now behind the mirror or in front of the mirror. This is what we have to speak. In terms of nature, we need to comment whether it is a virtual or real. How will you comment on this? If the image has been formed by actual intersection of rays, real image. If the image has been formed by dotted line, then it is a virtual image. Also, we have to say whether it is erect or it is inverted. Children, if my object is like this, this is my object, and if the image also comes like this, then I call it erect. And if the image has come in this order, then I call it inverted. So this is inverted and this is erect. Both are images. Okay? And in terms of position, then nature, and then the third one is all about size. Size, we have to just compare between height of the object versus height of the image. Three scenarios can be height of the object can be equal to height of the image, height of the object can be less than height of the image, or height of the object is greater than height of the image. ऐसा होगा क्या मतलब बोलेंगे जैसे it is me. Tomorrow I started contesting for the elections of Lok Sabha. So my images will be much bigger than me. What we call them? Magnified. Magnified. And my beautiful picture like that when I was very young, right there with my car, it is actually called it is called smaller than the object. It's the same size, but it is smaller. Your iCard photo has a picture of your face this much. Is your face this much like a lemon? No. That is a smaller than the object, but it's same. The ratio is same, right? And if it becomes very, very small, we have made your image so small, then we use the word diminished. Then we use the word diminished. बस यही तो है खेल. चले इतना समझ में आया? Okay. Object we will place at different positions. For every such position, we will get different images. For each image, we have to comment on PNS, position, nature, and size. When you talk about position, you say image is formed behind, in front with some specific parameters that we will see what are the parameters. Then we'll say that the image is erect or inverted, it is real, and it will say it is larger than the object or smaller than the object. Clear? चलें तो चलिए. Can I turn the page? Anurag? Yeah, very good. Okay. So my first case is object is placed at infinity. Where is infinity? Do we know? No. Infinity. So there is infinity. Much beyond that. We can't measure what is infinity. Okay? So let's see the image diagram for that. And a few thought processes as we make that. So make a concave mirror. And then draw your principal axis. Then name some points P, VF, and the C. Now your object, okay, the object, some of the assumptions that we have. Sir, why do you draw the mirror always on this side? Why don't you draw the mirror on this side? Well, the standard convention is incident rays will always travel from left to right, and object is always in front of the mirror. In lens, we can place this side or that side, but the object is always, otherwise how will its image be formed, right? Object is always shown by a vertical arrow, and the object by default is always taken erect. Sir, I love to take the object like that. ना ऐसा नहीं है. Object हमेशा erect रहता है. ठीक है? समझ में आया? So, and our object is where, beta? At infinity. Now, whenever you hear this word infinity, it is like some special things. The special thing is infinity means far, far away. And here there is one assumption. Rays from far, far off, far off source, or say object are considered to be parallel. You remember the dish antenna example which I gave? I had taken the rays because my dish antenna rays were coming from some satellite in Sat2C. So these rays are taken as parallel. Okay. Now, though your book will have one type of diagram, we will draw two type of diagram. This is actually this. Now many people say, sir, ये बड़ा difficult होता है. The first case is nothing but finding the focus of a concave mirror. ये नया कुछ नहीं है. It is just finding the focus of a concave mirror. That was Maggie. This is top ramen. Okay. Chalo. So let's make it. So we will have rays which are coming from far off objects. So these rays will be obviously parallel rays. So let's take some parallel rays. Ray number 1, then ray number 2, and they are coming from far off objects. Then comes ray number 3, then comes Ray number 4. Sir, I would like to draw the 6th ray also. Please draw. You have more time, you can draw. I don't mind it at all. So this is the first reflected ray. The rule, Acha, what is the rule I'm applying? A ray parallel to principal axis passes through the focus after reflection. Yes, first rule. And you can also say this is the basic of finding the what do you call focus of a convergent mirror. What has happened? Why do you don't draw? Huh? So this is my ray number 2, ray number 3, and ray number 4. Right? Okay. And after this, what I have done, I am just making this diagram small because I will draw one more diagram to explain you one phenomenon. I've just made it small. Hope you have understood this diagram, right? So I will now comment on, what do you call PNS. I will comment on, so when object is placed at infinity, number 1, image, okay, let me change the color. I'm not even more colorful, you know. Yes, Good. Okay. So we'll talk about the image now. Image is formed at focus. Image is formed at focus. Position we have declared. Where is the image? Focus. And you did not say in front of the mirror now because focus is always in front of the mirror for it. And if you want for more clarity, you can write here in front of mirror. Okay. So this is all about my position. Now I have to talk about nature. Nature. Did the rays actually intersect? Did the rays actually intersect? Yes, they did. So my nature is real. Erect or inverted? Inverted. Because in school, ma'am has taught us, in textbook it is written. How do you know inverted or not? I don't see any inverted image out here. Do you see? Did you at least see the image? Object? No, object was far away. How do you know this is inverted or? You don't know. Object was far away. Okay, our object is Uranus. Uranus inverted or non-inverted, how does it make it? But it's inverted, I'm saying. This is where you should learn science. It is inverted. That's why I made this diagram small. I'll draw one more diagram just to understand whether it is inverted or not. Okay. Now look, this far off object could have been the sun also. And the image has been formed at the focus. Are you able to make out any size of the object? Not at all. And the far off object could be the sun. In fact, if you focus a concave mirror on the sun, it is going to create a dot which will be a very bright dot capable of burning paper because all the rays are concentrated out here. Next time, don't try to see the sun with a concave mirror. You'll lose your eye forever. So we will say, I'm coming back on size. I have not spoken on inverted. That I will see, though I'm writing inverted, and I'll explain it to you why it is inverted. On size, I will say highly diminished. Highly diminished. Because it was the sun which you have made as small as a point. राघव समझ आ रहा है ना? तो ये इसको इसमें ये मत लिखना that it is smaller than the object. Smaller is like your iCard photo. You can still make out who it is. This is not smaller. This is very small. So we use the word highly diminished. Shall we see why it is inverted? Okay, let's see why it is inverted. Your wish. If you want, you can make this diagram. And if you think, nay, sir, I have understood, you may not. That's not a. Okay, so this is my pole, this is my focus, and this is my center of curvature. I'm doing some other thing, that is, I am creating. We learned about something called the focal plane. वो कब काम आएगा? वो अभी काम में आएगा. I'm not using focal plane. Okay, my far off object here. This was a very special case where I took the rays. They are parallel, but they were parallel to the principal axis. Now the rays will be parallel, but they won't be parallel to the principal axis. They won't be parallel to the principal axis. So let me take my rays. The rays are parallel, but they won't be parallel to principal axis. So my rays would be something like this. Number one ray, right? Number two ray, then ray number three. My rays are parallel, which are coming from far off object, but the rays are not parallel to principal axis. So what did we learn? That they will still now intersect on the focal plane. So let me bring them on the focal plane. I have to handle it with a lot of love and care. And for last 2 hours, I'm drawing only focal planes. My life has become a plane. Okay. So now I think I can make some sort of a peel of image. Look at the image. The rays which were coming from the head of the image have intersected here. An image is a point-to-point transformation of the object. These images somewhere erect, far away. You imagine the image is far away, erect arrow. The rays which are coming from the head of the arrow came and intersected here. So this is the head of the image. समझ में आ रहा है ना? The rule is rays coming from the point where they intersect is the image point of that object. So this is my image now. And don't you see the image is inverted? That actually says that the image is inverted. This figure से तुम नहीं बोल सकते it is inverted or not. From here you can understand. Is the concept understood? Right? So first law is very easy. कौन सा इसको समझा दो एक बार. Okay. Did you understand this? This was the case where the object is placed far away in infinity. So we took any far off object will always emit parallel rays. The rays were taken parallel. The rays are parallel and they have been made parallel to the principal axis also. As such, all of them pass through the focus. That means the image is formed as focus, highly diminished, real. My question was whether it is inverted or erect. This is an inverted, as you said. Now, how to understand inverted? I can't make it out from this figure. So what I said, let me take another source of rays. This time the rays are parallel because it's coming far off object. But the rays will also not be parallel to the principal axis. Now, children, I am mutating the diagram just for your understanding. Let's say the image is somewhere here now. Do you understand? This is the image. All the rays are coming from the head and they are converging here. So the head point's image is this. Have you understood? That actually proves that the image is inverted. Tail never changes because the tail will be dancing on the principal axis. Here also the tail will be on principal axis. Either your image will be like this or your image. तुम्हारा image ऐरा तो ऐसा तो नहीं हो सकता ना, either ऊपर या नीचे. भाई तेरे सर के रेस जाके यहाँ पे मिले तो ये तेरा सर है, पैर तो पैर ही रह गया ना. क्लियर हो गया? अच्छा, एक मिनट ये क्वेश्चन थोड़ा होल्ड करो. थर्ड इमेज से ये सब क्लियर हो जाएगा. थोड़ा होल्ड करो. Right now you gulp it. ठीक है? Shall we see this next one? Is this one clear? Next one is just opposite of this. Can I go ahead? Okay, let's see the next one. Next one is object placed at focus. अब बताओ. When you are far off, your image was formed at focus. When you are at focus, then your image should be formed at far off. If you are at far off, your image is forming at focus. If you are at focus, then your image should be far off. So Anvita, why do we need to remember image formation? If you know one, then the other one is auto understood. Our next, if you all have learned it in school, next will be between C and F. image will come beyond C, like a singer. So if the object is beyond C, image will be between C and F. So वहां से एक मिल गया. And the last one will be image at C, object at C, image will also be at C. एकदम clear हो जाएगा. अभी देखते रहो. Have you understood this? Okay. So let's see the next one, where we say, my order may be different from the book, but I'm deliberately making it so that things become clear. Object is at focus. Children, remember, we are studying everything for concave mirror. We're studying everything for concave mirror, and our object is at focus. So let's take it. Don't worry about we are going slow or something. I can finish this all 5 images in one day. It will make no sense to you because you will not understand either the head or tail of it. So please take time to understand. Okay. So this is my focus. I have a center of curvature and I have named my object as AB. AB is my object which is placed at focus. Right? इस साइड होगा ही नहीं, इस साइड लेंस में होता है, मिरर है, मिरर है, ठीक है ना? अब देखो, you will see the beauty of it. Just allow me to just give you some time. Okay. Now I say that a ray of light which is parallel to the principal axis. Children, tell me what happens to that ray of light which is parallel to principal axis? Passes through the focus. So that's our law. Passes through the focus. Are we fine? Okay. A ray which passes through the center of curvature, what was the rule? It comes back on the same path. In other ways, we say it is reflected, undeflected. है ना? Okay. Now, there is a little bit of anomaly, but anyways. So look at this diagram now. Look at the nature of these two rays. These rays will become parallel rays. Parallel rays. Now the beauty. Do you expect the parallel rays to ever meet? No. Sir, whenever they don't meet, you taught us to extrapolate them. Arey idiots, these are parallel rays. If you extrapolate also, they will be parallel. They will never meet. But we say, kabhi to mera bachcha acha banega. Someday I will lose weight. When? Someday. Someday. And that someday, we say, will meet at infinity. Parallel rays will meet, but will meet where? At infinity. Right? Huh? Any of what? Any ray through the center of curvature through the head. Any ray through the center of curvature, the mirror goes back in the same direction. Yes. What does it have to do with the object? The ray originated from the center of curvature, touched the head of the object and went. Let's come back. It is as good as the ray coming out from the head of the object, right? It is not one ray which comes out. Many rays come out. There is a ray which is coming out from the head of the object. Don't you think there will be one ray which is coming out from the head of the object which is actually originating from the center of curvature? That ray should come back undeflected. That's what has happened here. Is that fine? And the rays will meet at infinity. So let's talk about the image. Let's talk about position. Position. Now tell me, what is the position of this? The position will be, the image will be formed at infinity. We don't know where it is. बहुत दूर में जाके बनेगा. Very, very far off. Second, get me the nature. Are these real rays? These are real rays. And I said they will meet sometime in infinity. So if some meeting happens, the meeting is definitely by real rays, not by dotted rays. That means my image will be real. These rays have originated from the head of the image, and the head of the image is coming below the principal axis. So my image will be inverted. Very good. My image will be inverted. And now just look at the size. Just look at the size. It's not going to meet here. It's going to meet somewhere at Gujarat. The arrow will become very, very big. So the image will be highly enlarged. We'll come to magnified a little bit later. Highly enlarged. A very, very big image will be formed. Have you understood?
Why not magnified?
Magnified as a word, I will come little bit later. You're not wrong. Magnified is correct. But magnification, we say, 1 minute, beta. When you can make a sense of two, your, what do you call, it's a case of magnification, extreme magnification. Magnification is when you can still compare both your iCard photo and your face. In your case, your face is small, so both are almost comparable. Yeah, Anurag, tell me.
So I didn't understand how it is inverted.
How it is?
Understand how it is inverted.
How I tell it is inverted or not. Okay, look at my ray number 1. Can I mutate this diagram a little bit with a different color if you don't mind? So I'll make it a little bit kachra. This is the first ray. Where did it originate from? A or B? Tell me, Anurag. The object was AB. It originates, the yellow ray originates from where? A or B?
A.
A is the head of the object or the tail of the object? Head of the object. A ray which is coming out from the head of the object went below the principal axis. Are you fine so far? Okay. This particular ray has originated from the head or the tail? Tell me. From the head. And then it has got reflected back in the same line. So that means head is this side, head is this side. Head is below the principal axis. Do you agree or not? And they're going to meet far, far away someday at infinity. So even if my image forms, don't you think it will form this side? The head will come this side. Are we clear? Wa?
Yes, sir.
बहुत अच्छी बात है. अच्छी बात है. बच्चे को समझ में आ गया. Ajay bhai, anyone else has doubt? I really appreciate when somebody pulls up doubts. There is no point in crying later or then striking your head. As I told you, we have all the time in the world. If you have not understood, don't go by this drawing. It is parallel. Is this much understood? Yeah. Yeah, the larger the image will be. This is opening up like a fang of a crocodile. Like this. So the more and more you go. Ajay, Anurag, a nice diagram for you. Okay. Some nursery rhymes. We have a crocodile who has opened his jaws. If you put an arrow here, it is small. If you put here, it is even bigger. And if the crocodile was an alligator, then this is even bigger. Now, do you understand? Yeah, see? Our children love rhymes. This much? One application, just I'll show you. And after that, we will close. We have got 3-4 more things to see. Is these two understood? Okay. I want you to just practice these two. Don't practice more than that. Just see one more thing, that on the concept of what you call laws of reflection, image formation itself. Just see one more criteria. I have a concave mirror, right? And let's see, this is my principal axis. Okay, this is just for understanding. This is my focus, this is my pole, and this is my center of curvature. Imagine children, that I have rays which are coming out of the focus. A ray comes out of focus. Okay, a ray comes out of focus. Another ray comes out of focus. Another ray comes out of focus. Another ray comes out of focus. Apply your laws of reflection. A ray passing through the focus becomes parallel to principal axis. Very good. So this ray is expected to go in this manner. Do you agree? This ray is expected to go in this manner. This ray is expected to go in this manner. And this ray is expected to go in this manner. Am I correct or not? Yes. Now, I will mutate this diagram. This is the vintage 1922 Rolls-Royce headlamp. Do you understand? It's the vintage 1922 Rolls-Royce headlamp whose bulb was manufactured in such a manner that the filament of the bulb comes exactly at the focus. That's the job of the headlamp, that it will give you straight beams. Do you understand? And if you had old days torchlights, the steel wala, watchman wala torchlight, you could actually rotate the back side of the torch, and your grandfather or somebody will say that the focus is not coming proper. Focus means the torchlight should give you a bright yellow spot like this and one shadow spot like this. This is how you used to get a torchlight. So what your grandfather does by rotating the torchlight on the back side is moving the bulb back and forth so that he's able to get the bulb right at the focus and he gets this torch. सांस पढ़ना का थोड़ा सा एग्जाम्पल सामने बताया, नहीं तो बताओ example is important. You understand? Got it? And in cars of modern world, you need far more. So what you have done, you have gone from this model, even in Ambassador is still like this. But nowadays you have got paralleloid reflectors. You will see they are combinations of trapezium, parallelograms and all this, so that, and nowadays the bulb concept has changed. It's no more a bulb. Nowadays we've got LED lamps, right? And they will just grow up and give straight. This is the funda. And this was, and if I tilt it like this in this manner, isn't it my dish antenna wala example? So many things you have learned. The principal focus can be used to make a reflector. Same combination. आज का रंगारंग कार्यक्रम यहाँ समाप्त होता है. And in our next class, we will be learning about 3-4 more image formation criteria. But have you understood the focus and the infinity one? Have you understood this? Revise till this much and then come for your next class.